Okay, this is another video in the series here, and what we've done so far is we've modified our Festo Automation Suite base project to have the extended process data, as you can see right here. And the point of this video is to use this Festo extended process data AOI in the Studio 5000 environment. We've got a CMMT-AS series controller specifically that we're using today, and we have already created a RS5000 or Logix 5000 project, and we have created a connection as shown right here to the controller. We've got a connection set up. As you can see, we're online here. We've got a connection set up that is both our process data, which is our first 12 integers, and then our extended process data, which is 32 bytes. So we're going to go back offline here. And next thing we're going to do is we're going to import the AOI. So we've already discussed the fact that the AOI function blocks were downloaded right here. We showed you where to get those. And we downloaded that, and we've unzipped the zip file. And now we're going to bring that into our project. So depending on the version of Logix, find the add-on instructions, and we're going to click on import add-on instructions. Okay, and I want to navigate to the correct folder here. I already know what the folder is, so I'm just going to put it in here. Hit the enter button, and this right here is the extended process data file that, or AOI, that we downloaded from the internet, and we're going to import. Now you get this pop-up window here. The final name you can modify, but we're just going to take everything as default. You see here that it has some normal information, and we're going to click on OK. Performs the import, and brings in, and it shows you here that we have the code itself, which is not locked, which is nice, and we've got the process data itself. Okay, so now we want to add that to a project, and to keep things a little manageable and a little organized, we're going to do a new routine. We'll give it a name, and we'll open the routine. Okay, so I've just added this right here, which is a ladder program. For those of you who don't use Logix very much, there's a controller tag section right here, which, you know, it's accessible to all programs, all routines, anything that you have here for a tag. And if you have a program itself down here, then you have program scope tags, same idea, except it's only visible to the routines in this program. And first thing we need to do is we need to instantiate a instance of this extended process data AOI. So because we've imported it at the top here, if the software will respond, you click in the routine here, you click on add-on, and you'll see here that this is now here, Festo extended process data version 1.2. The definition gives you the version number, so we're version 1.2. Over here in the help file, we have very valuable information created from the manufacturer, which is Festo. You scroll down here, it adds this extended service description at the bottom here. and it shows you, who created this, the different versions, bug fixes, things like that. Give you a little bit of documentation. As well, the parameters themselves also give you an idea of what things are, which we'll look at in detail soon. So, to get the AOI here, we can click and drag over to here, or we can click in here and select this and add the device. I'm just going to remove some windows here and zoom in a little bit for everybody. So now we need to give it an instance, and in this case you need to add a tag. So how do you add tags? It's like I said, we can come up to the controller tags, we can put a tag here, and we can find the type of this, so Festo, and now we have this, and it's associated, that's an instance of it. And then we would come back over here, I use the control tab to switch, and I would paste that in there. Okay, now we have a tag. Alternatively, go back there and delete this. Right here, go back here. If you come into here and there's nothing there, see how it's an undefined tag? So it's undefined, and you would right click, say new. New. It immediately associates the correct tag type, and then you pick the scope. So I like to work with the PLC scope, the controller scope tags up here, and then you say create, and now it creates this tag right here. Okay. And if you expand the tag, you'll see that it's inherited the description comments from the add-on instruction itself. So let's just continue with the configuration here. We need to assign the inputs and outputs. So that's basically connecting to the real world. Let's go see what the user guide that is included with the manual offers here. So this is the manual here in the document directory. If I open this up here, okay, in the user manual here, we've got the EPD manual here. Go down to page 8, and it talks about the EPD input and output, and then it must be linked to the controller tag of the closed loop controller. Okay, so it doesn't give you much. The gist of it is that when we came into this controller connection right here, we added this right here. So these tags right here are the tags that need to be linked to that. Okay, so cancel, go to the controller tags. So you can come down through here and pick the data right there. Pick those and associate them. So I'm just going to Control C for copy, double click. There's your input data, and if you want to go pick it this way, you could go about it this way, same concept. Double click. Okay, so now this data is working. One other thing I would recommend is that you don't want to be sitting here scratching your head wondering why the data is not here when you don't actually have a physical connection. So if you come over here to the faves, add a bit, go back to those same tags there, and go to the input. Where is it here? CMMT, and go to the connection faulted. So make sure that there's no connection faulted in order to process the data. Okay, so we've got the general AOI set up and configured, and now we need to configure what we've mapped in the Festo automation suite. So It's not that complicated. It is in the user manual here. If I go back to the handbook, it shows you here that in this section, section 3.2, that a value here represents a data type in the code here. So let's just try and maneuver some stuff around. I'm going to try and maneuver this. See how small I can make this here. And move that out of the way. No. I'll come back to the video in a second after I've maneuvered dual screen here. Okay, so that I don't have multiple documents open, what I'm going to do is I'm going to transfer this data right here to the PLC and add a description comment. I'm going to right click and say add run comment and add some information right here. So I'll come back to that in a second. Okay, so what I have done here is given it a name. The EPD input output here is to and from the controller, which is these tags right here. And what we're talking about right now is this EPD config input and output right here. And the setup of these and what value you put in them is based upon what data types and how many objects you've configured. So as was in the user manual, if the data type in object 0 is a single integer, then you would put a 1 in here. And if it was a floating point, then you would put a 9 in there. And then for the next object in the row, moving left to right, you would continually populate that. So let's analyze what we have here. We have an unsigned integer 16. Okay? Unsigned integer 16 is the number 4. So I'm going to put a number 4 right now. Okay? The next object is a unsigned integer 32. Unsigned integer 32, go back here. Unsigned integer right here is a 5. So the next one over here, moving left to right, object is a 5. And then we have a 16 and a 32 again. So I'm just going to go keep continuing here. It's a 4 and then a 5 again. And then 4 and 5. And then the next one is a floating point. Well, the floating point in Rockwell is a real, and that's a 9. So the next one is a 9. And then the last one was a 32 again, so that is a 5. No, not an 8, 5. Okay, so this right here is configuring what this object is, this object, because the whole purpose of this Festo process data AOI is to convert the single integers or the bytes of information. It outputs it as a real value, but it converts it, you know, like that's what the whole code is all about. This gives you a little bit of an advantage. It only, as you can see in the user manual, it only accommodates for, where did I read that? Okay, so 64-bit data types are not represented here. Maximum length of 32 bytes, which is the real. And only one instance of this can be running at any time because it covers all 8 bytes of input, 8 bytes of, or not bytes, 8 objects in and out. Okay, so we are essentially configured now, and now we can download the project and see the data start to stream. Okay, so let's download it. We're in run mode. let's see if some data is coming through. Before we do that, I want to also point out that I've given the ID number right here of what each object is. So ID 0 is 30100, ID 0 is 30100. So the other thing I want to do here is I want to go to this here, because you can also use the raw data coming through when the data type can't be accommodated for. And I want to manipulate the data here, object 0, which is the input here, give it a description text. And do the same thing for the other ones. It's going to continue to add these here. Just so it matches what I have in the Festo Automation Suite configuration. As you can see, I'm an extremely fast typer. I would zoom in. Actually, let's see if I can do something here. Okay, there's my zoom feature, zoom tool. So object 0, 1, 2, 3, 4, 5, I've labeled 301 all the way and so forth. And that basically matches the extended process data that's configured in the Festo Automation Suite. And right now, wondering why I'm not getting data. Well, that's because we're not scanning this routine. So the right-click properties, you'll see here that this is a continuous task, got a watchdog. Program schedule is the main program only. I mean, we could add things, but I'm not going to do that. And main routine, I'm just going to add a JSR. So JSR, and then over here, double click, and pick that routine, and finalize the edits in this. And now when we go back here, hey, we have information flowing, okay? All right, so let's analyze the data coming in, okay? The one thing that's good and bad about the object here is that this is all real data types, okay? And when you have real data types, to get to the bits, it's not very user-friendly. So this device interface X1A is specifically bits, that each individual bit means something. So I am going to look at this from a different side here. And I just want you to know that this AOI doesn't cover all circumstances, because I want you guys to understand fully what's going on here. So let's close this for a second and let's look at the raw data. And when I said the raw data, I want to do a comparison between the Festo Automation Suite, which I'll leave open right there, to the raw data here. So we have the data, and I'm going to label just like I did here. I'm going to label the same thing in the raw data. So this diagnostic status is byte position 0 here. So the byte position 0 is this. And the second object here, copy, is in byte 2 starting position. I'll just continue to roll here, because the next byte position is going to be 6. So copy. Over here you can see that it says 6 is this one here, so paste it here. And then byte 8 is the next one. And byte 12. This one here, and then the final one here, copies in byte 16. Okay, So this is the process data in the AOI. This is the raw data. Okay, this is where everything's coming in. And yes, I have the data coming through and into the process data of the AOI, but because I can't get to the bit levels, it's more user-friendly to simply use these bits right here. And if you go back to the user manual, which one was it here? This one right here, where we talked about what these were. You know, like bit 2 is the control enable. Then theoretically I should label bit 2, so right here, as 10100 X1A bit 3 to match this right here. And I'm going to continue in this offline here to. Okay, so I've labeled these right here to match the user manuals so that I understand what each bit is for. And then I might as well add some code here. Add a rung, little operation, add some bits here, and take those bits. Wrong one, actually. It should be 16. And then the next one will be 1, and so on. And I'm going to add all 32 bits here. Okay, so I've added all the bits, and basically the process data is occurring every 20 milliseconds because of the connection that we've associated with already before. Let's quickly show you this again. So the connection, we set it up for 20 millisecond cyclical communications. So that data is coming in every 20 milliseconds. This right here, safe break, safe torque off, ready C1, ready C2, and the safe break. I'm going to hit the E-stop. You just heard the E-stop, so I've dropped out safe torque, safe break, and I've acknowledged or safe break or safe torque activated. That's how I call it. I don't call it acknowledged, I call it activation. So if I reset that, so you see here that the data is flowing, the data is changing over here, and that's essentially how to use the extended process data. To set up outputs, it's the exact same way, except you add the process channel down here, and then it'll be output data coming from the PLC to the Festo Automation Suite or controller. Okay, just be very careful with the writing of data that you have some initialization variables or values so that it's going to the controller. Otherwise, the controller is probably going to get 0 and have some sort of fault, and you'll be scratching your head going, what's going on? And, the next thing, yeah, and that's it. The next video I'll talk about a different way of utilizing parameters.